Hey DataCon, my name is Mike Farrell. I'm the CTO and co-founder of a company called Transcend. We're a data privacy company. I'm here today to talk a little bit about an encryption and to put that another way, why we didn't want to see any end user data and how we made it impossible for us to do so. So just a little bit of background about Transcend um, and how we started on this journey to try and operationalize data privacy for companies. Back in 2017, we founded the company. Myself and my co-founder, Ben, we came together with the idea that we wanted to give people more control over their personal data. We met as undergrads and we went on this mission together. And we kind of felt that it was hard, or companies collect a lot of data about us, but it's very hard to just get our hands on it. We were kind of like into that quantified self sort of wave, and we wanted to get our Fitbit and our Spotify and our Google search history and our health data, and kind of merge that all together and see any weird or interesting like correlations. And really at the goal of it was just like we thought, hey, if this data is about us and it's all over the internet, like we should be able to have it in our hands. And so we went out and initially started building a consumer product for users to just log in with Transcend, and we would integrate with all these consumer APIs, and give people a dump of their personal information. Um, Along the way, we learned a couple things. First of all, it's quite difficult to just like wrangle all this data. It's in a million different forms. It's not really standardized at all. Um, if you want to, so each API is a little different. Had to figure out those complexities. Another interesting thing was like we weren't always getting all the data we wanted. Like, yeah, it'll tell us you went and you liked this post at this time, but we were kind of interested in some of that deeper information, like, what was that like contributing to, and like how, what were like the downstream effects of that data, and then like were there any derived data or tracking data that was a little bit more juicy and interesting that these companies weren't showing us. And lastly, we started finding our data in places that we didn't want it. The more you go and look out for data around the internet, the more it can be a little scary sometimes to be like, wow, what's there about me? And so we did that for a little while, and eventually started talking to businesses about this problem. The Solving this from the consumer side was becoming a little bit more difficult. But around the same time, 2017, 2018 was when GDPR was coming into play. That's the European data privacy law. It was kind of the first of its kind, and there was a bunch that followed, like LGPD and CCPA in California. And so we started talking to businesses and started realizing that a lot of companies actually do want to reveal this information and give a good data privacy experience to the end user, but the problem is just incredibly hard for a company to do as well. It's not like all this data sits in one database, that you can run a single SQL query against and pull it all out. It's often around a bunch of different systems. There's a lot of human problems trying to interface between teams to get things on the same page. And it's a very expensive problem to solve. You have to get a lot of different folks involved in the company in order to do this right. And it's often not the most revenue generating process. So it's hard to prioritize something like that. So we kind of set out with the goal here of just like making it so easy for companies to do this that they can just use a vendor to figure out that and to interface with all these data systems that they have. So in early 2019, we launched kind of like the more modern day version of Transcend, where we had some early beta customers. And in 2020, we raised our Series A, serving customers like Robinhood, Indiegogo, Patreon, Open Door. And since then, we've been thrilled to serve many more companies across different industries. This year, we're excited to announce a new offering. We're launching a consent manager that integrates in with the rest of our products. And Ben Brooke, our CEO, is giving another presentation on that consent manager at this conference. And yeah, so we started building this, and one thing that we kind of realized about this problem is that it's super sensitive, and end-to-end encryption is kind of a must. We kind of realized it would be painfully ironic if we were out trying to, give people control of the information, but then at the same time kind of had this master backdoor key into all these companies' data. And so from the very beginning, we said, hey, we don't want to see any of this customer data. Like, it's not ours. We don't care about it. We don't, we want to be kind of the pipes that get that data to the end user. And so we started building out an end-to-end encryption pipeline. We made sure we wanted this to be true for all systems that we interacted with. So, if we're talking to an internal database or we're talking to a SaaS tool, it shouldn't matter. We want to be able to do a lot of the legwork, but not have any access to underlying customer data. We also don't want to hold access keys or API keys. It's if someone could get into our database and get those keys and then get access to whatever they have access to, that'd be a really bad thing. And so we kind of designed this all thinking that we ourselves may be evil, and we ourselves may be that person in the middle. And so, yeah, talking a little bit more about this pipeline. So just like a high-level refresher on end-to-end encryption in general, before we dive into our design here. So the most canonical example you probably hear of is like end-to-end encryption in the chat application. You have two users, like user A, user B, and they're sending messages back and forth to each other. And there's some centralized server that is interfacing and doing the networking between those two individuals. In this case, the users will have different keys, private key, public key. There's different ways to do it. And those packets will be sent back and forth. In the same way, we kind of think of ourselves as that chat server sitting in the middle, where user A and user B are the company, and you, the end user, that's getting your data. And so we kind of wanted to architect things in a way where Transcend as that middle chat server has no visibility into the packages that are being sent back and forth. And just one thing to note here too is that there's a little bit of a difference between a chat application and a file transfer system. Chat messaging apps, you're often, and most of the time, sending really small payloads. Like, you might have to handle an attachment or something like that. But you can often cap the size of the messages that you're going to be encrypting, which makes the implementation quite a bit easier. In our case, we do have some situations where we don't really want to have a file cap or a size limit cap on the payloads that can be encrypted, because we're giving people their data, and that data could be like gigabytes or even terabytes of information. And so, yeah, what's hard about this? Well, the browser and large file sizes and it all doesn't really work perfectly out of the box together. So if you have like a file and you're trying to download it and it's like gigabytes worth of data, you'll often have some route on a backend somewhere where you're just streaming that file from the backend server directly to your disk. But say that file is encrypted. That model doesn't really work anymore, because it would work, but you'd end up with a decrypted file on your computer, and you'd have to go and figure out what it means and how to unpack it. That might be like putting in a password or putting it through some software that would decrypt it. We didn't want users to do that. Like, if most folks requesting their data probably don't have the most, they're not always going to be like an engineer. And so we wanted to design this end-to-end encryption where everything is under the hood. The user doesn't really need to add special software. The decryption should happen on the client, on the browser, with no file size cap, and it all should just work. There should be no extra headache and able to get that file. And so for those that have ever used the WebCrypto API, you might be familiar with this fun little screen of death. The API works really well for small bits of data, and it's really great to use. And you can put up some encryption decryption pipelines pretty quickly. But as soon as you start getting into like the megabytes range, things start to be a little bit more difficult. There's a limit to the sizes that the ciphertext parameter, and it must be a buffer. So if you're pulling things into memory, there's like a theoretical size limit of about 512 megabytes using this API. So anything over that starts becoming really bad, or even anything close to that range, like around 50 megabytes or so, start to really freeze up the browser, and you'll start seeing like page unresponsiveness, because that main thread in Chrome or Safari is just doing so much work. So with all this in mind, we realized we kind of had to go out and we had to build something to make this possible. And so our solution is called Penumbra. And it's an open source library for implementing end-to-end encryption and decryption on the browser, for files that may not fit into the memory of a consumer's machine. So when we built this package, we had a few things in mind. One, we expected it to be browser-based. We didn't want that user to have to go download other softwares or do anything weird. We want everything to be in the browser. Two, there should be no file size limits. We might have massive files, we might have hundreds or thousands of files. We should be able to handle anything, and it should be streamable. And lastly, it should require low memory. We don't want to have to assume that we have to read or buffer something fully into memory in order to process this. So ideally, we could keep memory usage on the machine at a pretty stable or low point. And I guess related to that, if the memory is being consumed heavily, it shouldn't be stalling the web page. The user should still be able to interact with the web page while the decryption is happening, and it shouldn't block execution of the main thread. So yeah, a couple things that make this possible. First of which is leveraging writable streams. So writable streams are available in Chrome, Edge, and Safari, and they allow for files to be like parsed in chunks on the browser. So using this, we can stream a file from the back end, and apply like a transformation function on that stream on the browser. And in that transformation is where we can add decryption, and also another library we use called Conflux, which creates a zip and streams that to disk. We also make use of web workers. So web workers are just like a secondary thread that lives in your browser. This is really nice for when you need to offload really heavy operations out of the main thread. So your main, Chrome instance can be running and loading the JavaScript and HTML on the web page. But then we've like forked off another thread in the background that's running the decryption or other heavy operations. And those two threads can communicate back and forth with each other. The interface is a little difficult to use, but Penumbra tries to abstract away that interface and allow the developer to just, say decrypt this, and everything just happens, behind the scenes in the background. So here's a bit of a high level of like the full stream pipeline that we've built. So we start with buckets that sit in an encrypted S3 escrow. We compile those, and we won't go too deep into that, but we'll go out and compile those asynchronously. They're often files from a bunch of different systems, coming in at different times. We encrypt them all with the same key per request. So, the one end user is going to have their own encryption key that they can download all those files with. We then use the fetch API to fetch all those files in parallel. We then pass the results of those into to Penumbra, where Penumbra decrypts them all in parallel as well. After we've done that decryption stream, we pass them into another library we built, another open source library we built called Conflux. Conflux has a really simple API for building zip files on the browser. So it's really easy to specify the name of the file inside the zip folder, and construct that zip folder in a stream without having to buffer the entire thing into the browser. And then once we have that zip, we use Stream Saver to store it directly on the disk. And with that, the user will end up with just like this full download zip with hundreds of thousands of files, sitting on their machine like it was a normal download, but the whole thing kind of happened on the browser and decrypted, constructed into a file. And we were able to do this without, breaking any of the UI in the process. All the heavy data operations are in that separate background thread. And so here's an example of how we use this at Transcend. So here, this is what we call a privacy center. A privacy center is a place where our customers can host their privacy policies and also explain the different types of data practices that they use. On this page in particular, you'll see we have a side menu that kind of breaks down the different categories of information that Patreon collects on a user. And in fact, and this is a case where someone submitted a request to see their data. And we actually have a couple examples of it. So like down here, we have this JSON of your comments, and it's all the comments that we've ever left on our Patreon account. And the cool thing here is that this document is being decrypted with Penumbra right on the browser, using that same stream pipeline we just went through back here. The file is getting served up, decrypted on the browser, and displayed just right in line for the user to see. We can do this with any kind of documents, like we'll use images, audios, videos, each gigabytes in size. It all handles it fine. And the nice thing here, you can go and interact with this page. If you have a Patreon account, you could submit an access request at privacy.patreon.com. And you should see that the browser doesn't freeze up when it's doing all that decryption. You can still move around the web page just fine. And just to hop into a really quick demo here of how this all works. Here we have a demo sitting at penumbra.netlify.app. You can go and check this out if you want. But just if I reload the page, you'll see that all these files are getting pulled in, decrypted right on the fly. Some of these are decent sized images. And you can do a comparison here against WebCrypto. Sometimes it'll crash your web page. It's a little difficult to show on the video because of the video feed. But if anyone wants to come, it's at penumbra.netlify.app. Yeah, in terms of compatibility, we try to make the Penumbra package work with every browser. Not every browser has the same writable streams and transform streams, which make it difficult to keep that same no file size limit across every single browser. But we support Chrome, Safari, Edge, and Firefox all for decryption. Encryption for Firefox isn't supported yet until they add writable streams or transform streams, which I believe is somewhat on the roadmap. And we also try to make it so that if there are any weird complexities that different browsers do, that is all abstracted away into the Penumbra package. If for example the stream doesn't work, we'll try to fall back to something graceful and set a file size limit in those places. And the nice thing about that is, like, dealing with browser compatibility is hard enough on a regular website, but like when you're trying to use all these fancy cutting edge technologies like writable streams and web workers and all that, it's really nice to have the compatibility stuff just packaged under the hood. so that if you're using Penumbra, you just import it, you fetch the file, you decrypt the file, and you just don't care about the browser. It's just always going to do what you need it to do. And we'll expose sane fallbacks so that if something isn't supported on that browser, there's a clean interface for the caller to check for that. We ended up open sourcing Penumbra, and so we did this because, first of all, we think that there's more applications for end-to-end encryption across the web. There's probably a lot of cases where there's other SaaS companies or that are collecting data that maybe they don't need to, or just other different ways of using this technology with file streams in particular. So some other potential areas where this package may be useful would be something like a video chat or a file transfer messaging platform. You could do things like end-to-end encrypted live video feeds or something like that. Often can be difficult to do, but if you can do it with the streaming, we could handle larger videos and just stream those as they're recorded. You could also have like a better drop storage platform, kind of thinking like, imagine you had like a Dropbox, but the Dropbox had no access to your information, and you held the keys on your devices. Interesting things there, because you could build a different sort of storage platform where you actually don't need access to that information at all. And another example could be like a journalist or a human rights platform that needs some way to send sensitive information between groups in some area where maybe the network is untrusted. You could, using our package, you could encrypt or decrypt large files right on the client side, and prevent, you don't really have to trust the network so much. In terms of future developments, there's a couple things we've been thinking about here. One is expanded accessibility and browser support across the board. Overall, it's pretty good these days, but there's just a couple places too where we'd like to have more sane fallbacks. Some of the older browsers in particular can be a little bit funky to manage. Another thing we want to do is improve the API of the web worker communication channel to just simplify things a little bit from the caller perspective. Again, it's not too bad right now, where like you can say, penumbra.encrypt, penumbra.decrypt, and all that happens in the web worker behind the scenes. But if you wanted to get a little bit more granular and start controlling more of that web worker, and like say, the number of threads, or just like a more graceful way of handling errors in particular threads, we want to just simplify that interface a little bit so that the caller has even less of a knowledge that things are happening in some background thread. And another thing, we want to increase the flexibility for different encryption schemes. When we built this package, we kind of went and we did our research and looked at what the industry standard was for end-to-end encryption pipelines, and we built that into Penumbra. But sometimes folks want to use their own strategy. They've done their own research and have a reason to use another encryption scheme, and we want to be able to support those. It's really not too difficult to add more, but yeah. And then lastly, we want to upgrade things to take more advantage of hardware accelerated web crypto. Interestingly, a lot of this stream stuff is pretty new these days, and so there's a lot of developments being pushed out in different browsers kind of like every year, and so just keeping up with those and making sure that we're decrypting and encrypting things as fast as possible on that machine. And yeah, we have other open source projects as well. If you go to transcend.io/open source, you'll see some other things we have there. Penumbra and Conflux were the two we talked about today. They're both the browser-based packages for decryption, encryption, and managing zip files. We've also got a lot of cool Terraform modules. We're a pretty big Terraform Terra grunt company with, we have like thousands of modules, and got some good open source packages there. We've also got some great engineering blogs if folks want to check it out. And yeah, overall, that's all I've got today. Again, my name is Mike Farrell from Transcend, and my email's here. You can check out our GitHub as well for some of that open source material. But thank you, DataCon, and it was great to be here.